We did yesterday. So we started off with recapping the basic properties that we had already learned. The logarithmic basic properties, algebraic properties. Then started working with change of base. So remember, your calculator can only work in base 10. If you want to work with anything else, you have to use change of base formula, which is log of A divided by log of B. So on yesterday we did 3 examples of how do we rewrite it, and then how do we go about solving it. And then we finished up yesterday with using change of base formula to solve exponential equations. The vast majority of the time, it involves a rewrite and then using the change of base formula, at least for the basic equations. So 8 and 9 will still fall in that basic category. Once we get to 10 and 11, then we change the rules a little bit, because doing a basic rewrite is not going to help. So let's go back to problems 8 and 9. Essentially just to recap what we did yesterday with solving the equations, and we can go from there. So problem 8. 2.1 raised to the a plus 2 power equals 8.25. So just like we did on yesterday, your first step is going to take this and rewrite. So rewrite as a log. Rewrite as a logarithmic equation. So there's your base, there's your x, there's your y. So that gives you log base 2.1, 8.25 equals a plus 2. So the first thing you have to do is do a basic rewrite. Now that we have a basic rewrite, so now we're going to use change of base. So again, change of base is what we need so that we can use the calculator. So that expression is rewritten as log 8.25 log divided by log of 2.1. Any questions before we continue? All right, then let's let our calculator do our work. We've got our calculator ready to rock and roll. Remember the log key next to the number 7 underneath the x squared. So you have log of 8.25 divided by log 2.1. So you end up with 2.84419, a whole bunch of numbers. So again, we go to 3 decimal places unless directions tell us otherwise. So 844, there's a 1 behind it. That 1 doesn't do anything. 2.844 equals a plus 2. So to get a by itself, subtract the 2 over, so 0.844 equals a. And that's your final answer. So again, the main two things there, rewriting it as a logarithm using change in base. Other than that, it's fairly a straightforward equation. Any questions, debate? If not, then let's go to 9. So 9 amounts to the same thing. So for problem 9, we do our rewrite. There's our base, there's our x component, there's our y component. Log base 7, 20.42 equals x squared. So we do the rewrite, and then use change of base. So the first 2 steps, for some of you, will take a lot less time than I'm showing it in. They're pretty simple steps to navigate through. So now we let the calculator do its work. Log 20.42 divided by log of 7. Make sure I type everything in correctly. So 1.550. Equals x squared. So this time we have x squared. Okay. We can get rid of x squared. Square root of both sides. So you have x equals plus or minus 1.245. So what was so different about it? Nothing really. The only thing that happened was we had x squared, take the square root of both sides. You can have negative answers for an exponential equation. Exponential equations can take any number. It's logs that can't take 0 or negative. But an exponential equation can pretty much do what it wants. So, any questions? 8 or 9? Okay, those are very similar to what we did yesterday. And it allowed us to use change of base. So for those of you that missed yesterday, you really didn't miss all that much. Give it another few seconds for anyone that's still copying down. right? So now we're going to switch ourselves into something just a little bit more complex. Not too much complex, but just a little bit more complex. So for examples 10 and 11, a basic rewrite is not going to work. A basic rewrite is not going to work. So here's why. If you look at examples 6, 7, 8, and 9, each of these equations is equal to a number. Each of these equations were equal to a number. So it made it very, very easy to rewrite it and then go about solving. If you look at 10 and 11, you have an exponential expression equal to another exponential expression. So normally, when we had problems like this, we would try to make both of the bases match. But there's no way that I'm going to make the 4 a 6 or 6 a 4, and there's no number that I can get to line up with it. Same thing with the 5 and the 11. There's no number I can get to line up. So on the surface, it looks like we're stuck. But since we have logs, and since we have properties of logs, we can actually work this problem out. It does take a little bit of time, but we can still work this problem out. Let's start this process with problem number 10. Go pretty slowly with problem number 10. That way, if you have questions, please ask. It's not going to bother me to stop and have to answer a question. So, the first thing we're going to have to do, since we can't rewrite the 6 or the 4, we're going to take the log of both sides. We're going to give the log to both sides. So both sides get a log. That's the first thing that we do. So now, you have log 6 to the p minus 1 power and log 4 to the p power. So we're going to use a property. We're going to use the power property. So we're going to use the power rule. So remember, for a logarithm, if you have something raised to an exponent, you can take the exponent and move it out in front. And take it and move it out in front. So for the left-hand side, that gives you p minus 1 times log of 6 equals p times log of 4. So all we did was take the exponent, move it out in front. Any questions before we continue? All right. So next thing. So we have logs on both sides. So we're sitting here right now with logs on both sides. Logs on both sides and variables on both sides. So what we're going to do is move the logs to one side of the equation. Variable to the other. So you have p minus 1 times log of 6. We're going to move the log of 6 over to the other side. So to do that, we need to do the opposite. Opposite of multiplication is division. That's p minus 1 equals p times log of 4 divided by log of 6. Now I want the variable on the other side. So this p, I want to move it to the other side. P is multiplying times that, divided on both sides. Now those drop out. So p minus 1 over p equals log 4 divided by log 6. That's a number. That's a number that we can put into the calculator and get. So we're going to put this into the calculator. Log 4 divided by log 6, 0.774. So now here's what our equation looks like. If something's not clear, make sure, feel free to say something. Doesn't hurt my feelings if you have a question. So again, it's not a harder problem, it's a longer problem. And I'm probably going a lot slower than some of you all need me to. But that's okay. So you got the logs on one side, the variables on the other. We put that into the calculator. Now we're going to cross multiply. Now we're going to go ahead and cross multiply. So you have 1 times p minus 1, 0.774 times p. So p minus 1 equals 0.774p. You don't want variables on both sides. So I'm going to move subtract p on both sides. .774 minus 1. Negative 0.226p. Then you divide. So you end up with 4.425 equals p. So just to recap what each of the steps were. Use my highlighter for this. So we started out by giving the log to each side. Gave the log to each side of the problem. Then we moved the exponents on each side. We used the power property and moved the exponents. After that, we moved the logs to one side of the equation and then the variables to the other. That's why we divided log of 6, and then we divided the p, and this is what we ended up with. Last step in all this, cross multiply. That's where all this came from. So again, it's not as if any of the steps are difficult. You do have to take your time, make sure you're doing everything correctly. So, any questions? Any place where you got stuck? Any question you're concerned or confused about with example number 10? We will do another example of that very shortly. So we got that after we subtracted p on both sides. So 0.774 minus 1. So minus p is the same thing as negative 1. So 0.774 minus 1 gives you negative 0.226.
Verify that just to make sure I didn't screw up.
So, good question there. Appreciate that. Anyone else with questions on example 10? Right? Let me give you. All right, so let's start navigating through. So the first order of business is to take the log of both sides. Take the log of both sides. So we have a property that we can use that allows us to move these exponents. So if we move the exponents, that gives us b times the log of 5 equals b minus 3 times the log of 11. So now we want logs on one side and the variables on the other. So the log of 5, I'm going to move over to the right. Log of 11 over log of 5. And then b minus 3 divided on both sides. That gives you b over b minus 3 equals log 11 over log of 5. That can go in the calculator. That's just a number. Log 11 over log 5. So 1.4898, 1.490. So, any questions getting to that point? Again, not a hard problem. Just one that takes a little bit of computation. So now this becomes a cross multiplying problem. So go ahead and cross multiply. B times 1, B minus 3 times 1.90. So B times 1 is B. 1.490 times B minus 3. 1.490 B minus 4.47. So again, I cross multiply. Get variables on both sides, so take care of that. 0.49b equals negative 4.47. And then divide. So you choose 9.122. So again, the main mistake that could be made, will probably be made, is more so rounding than anything else. But as long as you're using the properties the right way, there aren't too many places to make a mistake. Any questions on example 11 or any place where you saw yourself getting stuck? Before we move to a word problem example to finish up. All right, of course, if you end up with questions, this is going to Google Classroom, so you're more than welcome to look at it as much as you want. All right, example 12. The number of pet owners in thousands after T years can be modeled by that equation sitting up there. Let T equal 0 represent 2,000. Use the change in base formula to answer the following questions. All right. So we have a two-part question here. They're giving us an equation to work with. So they tell you that number n is in thousands of years. I mean, is in number of pet owners in thousands. So that means if you get 1, so 1 is the same thing as 1,000, is what they're trying to tell you. 1 is the same thing as 1,000. And they're telling you that T equals 0 represents the year 2000. So T equals 0 is 2000. That means T equals 1 would represent the year 2001. If you're talking about the year 2021, this year, that would be 20. So for part A, when they're asking you how many pet owners were there in 2005, so 2005 means that t equals 5. So there are some minor conversions that you do need to know how to do, just like you would need to do that in a science class. So again, if you're stuck, make sure you say something. Let's see. Oops. It's not all the way fit. All right, so let's work out part A. So t is equal to 2005. So t is equal to 5. And n equals 35 log base 4 of 5 plus 2. Let's see. Go ahead, Morgan. Morgan? Morgan? All right. Well, make sure that she raised her hand. Let's keep going. All right. So we work out the problem. 5 plus 2 gives us 7. We have 35 times log base 4 of 7. So to work this problem out, we have to use change of base. So we need to take this part of the problem and rewrite it. 35 times log of 7 over log of 4. But if we do this correctly, we can let the calculator basically handle the rest of this. So log of 7 divided by log of 4. This is 35 times log of 7 divided by log of 4. 1.404. Multiply it times 35. You get 49.14. So 49.14 means 49,140 pet owners. Because remember, the number was in thousands. So that means 1 represents 1,000. So 49.414 is 49,140. So part of this is also interpreting the question correctly, which those of you who are taking the SAT next week, there's a lot of reading and interpreting that you're going to have to do. Questions on part A before we do B? All right, so let's work out B. Let's see. Morgan, your hand is still raised. I don't know if you did it on purpose, on accident, or just when you know it's there. So, how long until there are 70,000 pet owners? So, I told you N was the number of pet owners. So that means you're taking the equation they gave you and putting 70,000, using 70,000. So remember, just like 1 is equal to 1,000, that means 70,000 is equal to 7. So you're not going to plug in 70,000. You're going to plug in 70. You're not plugging in 70,000, you're plugging in 7. So let me circle these two parts. And the part that says it's in thousands. Just in case you're wondering why did it do that. So, to solve out the problem is actually pretty simple. This 35 can't stay there. It's multiplying times the log. So we're going to divide it and get rid of it. 2 equals log base 4 g plus 2. So we have a log equation. So now we need to rewrite it. Here's your base. Here's your y component. Here's your x component. So now we're taking a log and rewriting it as a exponential equation. 4 to the second power equals t plus 2. But this ends up being a fairly simple equation. 4 squared is 16. So 14 is equal to t. Any questions before we finish off the equation? We'll finish off the problem. We're done with the equation. All right? So to finish it off, you have t equals 14. That is not your final answer. They told you in the problem, t equals 0 represents the year 2000. So if t equals 0 means the year 2000, that means t equals 14 is the year 2014. So the year 2014. So when will this occur? 2014. So again, for my juniors who are taking the SAT next week, for the sophomores that are in here that are taking the PSAT next year, a lot of what the test is you doing a lot of reading. Even in the math section, you got to read in order to interpret the problem correctly. Again, the sophomores, you're taking the PSAT. That test qualifies you potentially for scholarships. So definitely take it seriously. If that's something you're trying to go for, hopefully everyone's trying to get some scholarship money. Put in some time to practice and do what you do. So, any questions by anybody before we wrap this on up? Not seeing here, so go ahead and stop.